We're going to keep with division, but this time we're going to talk about a different method. And this method is called synthetic division. So it's a little bit, it's kind of like a shortcut. And so again, you can go ahead, do this problem with long division. You'll get an answer, but I'm going to show you another method to solve it using synthetic division. So the first thing I got to do is I got to figure out, first thing I got to do is figure out what makes my denominator, again, what makes this part equal to 0. So side work, I'm going to set it equal to 0. And if I subtract 4, I get x equals to -4. So when I do synthetic division, something like this, I'm going to put -4, again, that I got right here on the outside. And then I'm going to go through and I'm going to mark down the coefficients of what I'm trying to split up, what I'm trying to divide. So the coefficients, remember, are the numbers in front of the of the variable. So I'm going to get 3, -5. Yes, you have to use the positives and negatives. 6, -7, and 9. So now what I need to think about is, first step I'm going to do is I'm going to bring this 3 all the way down. And I'm going to say, all right, I'm going to rewrite this as a 3. And now I'm going to multiply 3 times -4. And 3 times -4 is going to give me an answer of -12. And so to move over to get my next line, I need to add -5 plus -12 gives me -17. And now I'm going to repeat that same step. I'm going to take -17 and multiply it by -4. So -17 times -4, and feel free again to use a calculator, that's going to give me 68. And now I'm going to take 6 plus 68 and get 74. And again, I got to keep going through this process. 74 times -4 is -296. I'm going to add -7 plus -296, get -303. And then my final step, I'm going to -303 times -4 gives me 1,212. And when I add those two up, I get 1,221. So this is going to give me the coefficients to the problem that I'm trying to solve. And now I just got to remember that I have to take, my answer is going to be 1 degree less than what I started with. So I started with the highest degree of x to the 4th. So I'm going to write my answer as the highest degree, 1 less than 4 is 3. So I'm going to say that this answer again is 3x to the 3rd minus 17x squared plus 74x minus 303. And then my remainder gets put over what I was dividing by. So plus 1,221 over x plus 4. That's going to give me my final answer. This is, again, the method. This method is called synthetic division. Another application of synthetic division is potentially finding out, what specific x, like what the y value is for a specific x value. So if I look at the function 2x to the 3rd plus 5x minus 9. Now, I would say that, this is not necessarily that hard of one to do by hand. And again, you're right, it's not. But if we got a longer one, again, we could have a degree of 100 and it's going down 99, 98, 97. And you would not want to do that by hand. So let's go ahead and we'll check our work. So if I plug in f of 2 here, and again, every time I see an x, I'm going to plug in a 2. Okay, and again, this one we can do by hand, actually. Okay, 2 times 2 times 2 is 8, times 2 is 16, plus 10 minus 9, 26 minus 9. That's going to give me 17. So f of 2 equals 17. But what if I wanted to use synthetic division? Like I said, what if we had a ridiculously long polynomial? There's no way we're going to enter it all in like that. So what we could do is, again, because we're looking for f of 2, we're going to divide the function by 2. So I'm going to use my synthetic division idea. And again, do not forget x to the third, x to the first. We're missing x squared, so we have to plug in a placeholder. So again, my coefficient is a 2. My coefficient for x squared, it's like 0x squared, so I'm going to use 0. My coefficient for x is 5, and then my constant is -9. So about going through my technique, okay, I've got to bring this down. How many times? 2 times 2 is 4. So 4 goes here. Bring it down. 0 plus 4 is 4. 4 times 2 is 8. 5 plus 8 is 13. And 13 times 2 is 26. And -9 plus 26 equals 17, which, if we look over here, is exactly the same thing. So we can kind of use the synthetic division idea to evaluate certain polynomials. X to the third minus 5x squared plus 2x minus 3. Again, I want to find it. I know that if I were to, again, if I use my calculator, if I do it the other way, I get f of 3 equals -15. I'm going to go ahead and, again, I want to find out, say I didn't know that. Say I didn't have a calculator. I would say it's equal to 3. Okay, I'm going to go down, set up my coefficients. 1, -5. Make sure my degrees go in decreasing order. It looks like they do, so we're in shape. We're in good shape there. -5, 2, and -3. Again, I always kind of write it. There we go. Again, start by bringing down your first one. Okay, 3 times 1 is 3. -5 plus 3 is -2. -2 times 3 is 6. -6, which gives me -4. And this gives me -12, which gives me -15. We double checked, and yep, that's exactly the same thing. So again, can be sort of a quick way to evaluate certain numbers at for a long polynomial. I can also use synthetic division to help me factor. So again, if I'm thinking, what are the factors of x to the third minus 7x plus 6? Again, just a little bit of side work or sidebar. I look at my constant and I say, what are the factors of 6? Well, that's going to be positive or -1. Again, 1 times 6 is 6, positive or -6. And positive or -2 times positive or -3. So again, I've got 1, 2, 3, and 6 as possible factors. So if I were to think about it, okay, I'm going to say, well, I'm going to check that. And I want to go in and say, okay, if that's true, I'm going to use synthetic division. I'm going to say, well, what's my coefficient? The coefficient here is 1. Okay, again, and so because my coefficient is 1, the only factor that, again, that's going to have is positive or -1. So when I think about setting this up, I'm going to say, let's just pick one. Let's try 1. So I'm going to try using synthetic substitution with 1 because, I'm just going to start by plugging it in. And so I'm going to get, if I plug it into my equation, 1 to the third minus 7 times 1 plus 6. 1 minus 7 plus 6. That is going to give me -6 plus 6 equals 0, which is a true statement. So I do know that 1, when x equals 1, is a factor because it equals 0. However, again, when you write it, if x equals 1, really the factor is like x minus 1, because again, if we have to set that equal to 0, 1 minus 1 gives us 0. So once I know that I've got a factor like this, I can use synthetic division to help me sort of narrow it down. So I put 1 out here. And again, my coefficient, if there's nothing, it's a 1, -7, or I gotta remember that placeholder. Again, I skip 0x squared, so I actually have to use 0 here, -7 and 6. Again, as I bring this down, 1 times 1 is 1, 0 plus 1 is 1. 1 times 1, -7 plus 1 is -6, and 6 minus -6 is 0. Again, when we get a remainder of 0, that's what we like, because it basically goes away. So we want a remainder of 0. And again, because it ends in a 0, I know that it's a factor. Again, we did it up here, but say you were to have a really long, complicated equation, you would want to potentially use this to help you out. So now I got to figure out, all right, well, let's use these to write what's left. So again, I always take 1 degree less than what I started with. I started with x to the third. So this is like saying x squared plus 1x minus 6. So I know that I've got a factor of x minus 1, and I've got a factor of x squared plus x minus 6. From here, I can use my factoring x. So I'm going to think, what two numbers add up to get 1, but multiply to get -6? Well, that's going to be a +3 and a -2. So when I write this out, I'm going to say x plus 3, x minus 2, and then I still have my x minus 1 from the beginning. So I was able to use synthetic division to help me factor x to the third minus 7x plus 6. Again, I'm looking to factor this equation. So my first thought process is, what are the factors of 6 or -6? So again, all right, what are my factors? It's going to be the same as before: positive or -1, positive or -2, positive or -3, positive or -6. And it's a good idea to sort of check +1 first. +1 is kind of an easy one to plug in. So again, if I'm going through this, I'm going to say 1 to the third plus 4 times 1 squared plus 1 minus 6, 1 plus 4 minus 5. And again, if it equals 0, we know that it's a 0, and 5 minus 5 does in fact equal 0. So I'm going to rock and roll with that. I'm going to say, okay, well, I know that x equals 1, but again, that means the factor is x minus 1 because it has to equal 0. So when I'm using synthetic substitution, now I'm going through, I'm looking for my coefficients. My coefficients are 1, 4. Again, it goes in order, so I don't have to add any placeholders on this one. Start by bringing this down. 1 times 1 is 1. This gives me 5. Move it over. 5 times 1 is 5. This gives me 6. 6 times 1 is 6. -6 plus 6 is 0. That's my remainder. That's kind of what we want. So I know that x minus 1 is a factor, and now I've got these coefficients. Remember to subtract your degree by 1. So this is like saying x squared plus 5x plus 6. Very similar to the last one. So again, I'm going to use my factor x to help me determine. Again, I take what two numbers multiply to get 6, but add to get +1. Okay, it's going to be, or excuse me, they add to get +5, and they multiply to get 6. Well, that's going to be +3 and +2 this time. So again, when I write it, I get x plus 3, x plus 2, x minus 1. That's how I'd factor it, which again, what are the zeros? My zeros would be x equals -3, x equals -2, and x equals +1. Last example here. 2x to the third minus 3x squared minus 2x plus 3. Again, figure out what are your factors. What are your factors of 3? Really, my only factors of 3 are 1 and 3. So again, I like to always try, if you can, try +1. So plugging in 2, 1 to the third minus 3 times 1 squared minus 2 times 1 plus 3. 6 minus 3 minus 2 plus 3. Does it equal 0? Does it equal 0? 6 minus 3 is 3 minus 2 plus 3. Oh, right here. I knew I made a mistake. 2 times 1 is 2. There we go. So yes, it is going to cancel out. 2 minus 3 minus 2 plus 3, 0 equals 0. So we know that x equals 1, which means the factor is x minus 1. So I'm going to go about using synthetic division again. So I get, again, setting it up, 2, negative 3, negative 2, 3. Bring this down to negative 1, negative 3, and 0, which is nice. So what's left over? Remember, you got to decrease your highest degree by 1. So that's like saying 2x squared minus 1x, or again, we could just do minus x minus 3. And then I also have x minus 1. So now the question is, how do I factor 2x squared minus x minus 3? This doesn't have a coefficient of 1. So it's a little bit more tricky. So I got to take my constant and my highest degree coefficient, and that's going to give me negative 6. So I'm looking for two numbers that multiply to get negative 6, but add to get negative 1, because it's got to add to get my middle term. So I'm going to say, well, that's going to be negative 3 and positive 2. So I'm going to take this term, and I'm going to rewrite negative x as 2x squared minus 3x plus 2x minus 3. Again, all I did was change the middle. And now I'm going to sort of group them together. I'm going to look at this term and this term together. And I say in my first term, 2x squared minus 3x, I could factor out an x. And when I do that, I'm going to be left with 2x minus 3, which is actually what I have in the other term as well. It's factoring by grouping. So that's really nice, because I'm just going to factor out a 1. That doesn't really change anything, right? And now, because these two are the same, I can go ahead and combine these two together. So I can get x plus 1 times 2x minus 3. And then don't forget, we initially had the x minus 1 as well. So this would be my factored form for the problem. And then again, if I was looking for zeros, I would say 1, negative 1, and positive 3 over 2, or 1.5.